Hello, my name is James Halderson. I am the lead developer on the Thetis Block Matrix project. And today we're going to be doing an update and a devlog on how the project is going. I'm happy to say that we currently have two nodes running. They're both on my local machine right now, but they actually are communicating on the back-end network right now. So we have a testnet actually functioning right now for the block matrix. So I'm going to go into this presentation that I've done before, but I will actually show things in operation as it goes along. The first thing that we're going to do right now is we're going to introduce the concept of a block matrix and how does that differ from a traditional blockchain. So what is the Thetis Block Matrix? A block matrix is a new innovative idea in the blockchain industry. Essentially, a block matrix is an ecosystem of several different blockchains that are all interconnected and communicating with each other's individual blockchains. How the Thetis ecosystem will work is each individual account has its own blockchain. This account can hold several unique data types that are owned and possessed by the associated account, including token wallets, NFTs, and encrypted blockchain assets. So we'll go into our little thing here, our little diagram. So this is a traditional blockchain. The difference with the block matrix is that each one of these accounts, let's say X, Y, and Z are their own accounts, they each have their own blockchains. And these blockchains contain block data, of course, but also these have account assets. So these blockchains and account assets are actually decoupled from each other, from one another. So when I make a transaction, for instance, my data will be put onto my data block here, put in a data block onto my blockchain. And if I send an account asset, you would receive that, and then that record would be on both. It would say, hey, I sent it on mine, and then yours would say, hey, I received it. So last night we did the first transaction between two nodes. About a week ago we did the first transaction on one node, sending to itself to test out the backend network. Last night we did one on two nodes, and we just previously did one about 5 minutes ago, but I have to restart this little presentation here because something went wrong with my recording. That's fine. We can continue on here. So we can go right into our nodes here and show that we have two of them. This one has 400. That's the two 200 transactions. This one has 596. It started at 1,000. So there is small. I ended up implementing a small transaction fee, which I wasn't going to originally do because there's no mining or anything. These blocks mine themselves. These blockchains mine their own blocks, let's say. There is no actual mining. It's just that they actually do the encryption and they figure it out on their own. They encrypt and hash and everything on their own, so they doesn't require some external third party to come and mine it and validate everything because they're all self-validating blockchains. So just a brief overview of our little application. These are both client applications. We got our test node, that's the name of your account there. Here's our balance in USD. These are just test values. It's not actually 500 something USD right now. In the future, you will be able to buy through here, buy and sell to a PayPal account, a PayPal Holdings account. That's the ETS token concept, which has been revised since I initially imagined it. It's no longer going to be based upon an average of different coins in the market, because what I realize is that concept, it would be excellent for avoiding losses in a bear market. But in a bull market, you actually have the potential to lose a lot of money, because if the coins go up crazy, there's not, like, the liquidity isn't changing when the coins go up 200% in a single day or something crazy like that. So because of that, the idea of having it constantly liquid at 100% liquidity, it's just not feasible if I'm tying it to other assets, unless I hold those assets, which I don't hold those assets right now, at least not to rationalize the value of this ETS. So I revised it, so now ETS will just be based on its own holdings account, and I can go into that in a different video. But for today, we're just going to be showing off the test transaction and showing off the test net in an operational state. We have our send button here. This goes to the send page, which you can also access through the menu up here. This will be viewing your own transaction history, and this will be to view the whole network. It'll be in Blockchain Explorer, but it's actually a Block Matrix Explorer, so it'll let you explore any active blocks that are out there currently, and a record of all that. And then there's the EBAs. So EBAs are operational. That's encrypted blockchain assets. So these encrypted blockchain assets are operational right now because that's how the wallets are actually operating, is their encrypted blockchain assets. And I'll go into more of that in a second. But this idea of showing you your encrypted blockchain assets in here, and then you'll be able to, like if it's a music file, if it's a video file, you'll be able to actually view it in here. And you're the only person that can view it. That'll be something we'll talk about in a bit. For now, we're just going to jump into going to our send page, which might take a couple clicks because it's running on a network. As you can see, it updated there with 0, and then it updated here. So it has to, download the wallet file. It has to unencrypt it, decrypt it, and bring over all the data back into here to bind to here, and so that we can look at it and visualize it here in the UI. So without further ado, let's do a transaction here. So we'll say, I don't want to send 200 again because I'm going to run out of, I only generated, there's only 1,000 of these tokens in existence right now. So I don't want to start running out of them. So we'll just say 100 this time instead of 200, which was what I did for the first 2 transactions. I don't know why I chose 200, it was kind of arbitrary. But, so now if we want to get the address for this guy, you're going to have to know the address here to be able to send something. We can come here and we can look here. This is actually in the nodes here. So there's 2 nodes on my machine. This is node 1, this is node 2. When I open this up, this is actually the blockchain object. These are going to be compressed and then put into the network. That's already been set up. It's just that for now, so I can visualize it, it's a lot easier for me to just keep them local on my machine and look at the blockchains as changes are made. But in the future, none of this will actually be happening on your computer. It'll just be out there in a file share somewhere, and when you make a change, it'll update the file share and you won't have to deal with this. But I'm going to rename this. This is the name here, the address of our account that we want to send to. And then as you can see here at the end there's a BC, and that just means the blockchain file. So the wallet file is the address name. That's how if you looked at it, it would be this address. And then the BC is the blockchain file that's associated with that address. If we look in here, we can actually look in here for now. Like I said, in the future, which these operations have already been tested, I'm just not using them at the moment. This will be a compressed object that will be put up in a file share somewhere in JSON format, so that you don't have to deal with that at all. Also, it looks like we have a little issue with timestamp again, which is fine, and I know how to fix that. Yeah, anyway, so here we can see that we have a receipt and another receipt here. I'm going to have to make a change to the timestamp here because saying 0, that happened before. That's just because I haven't, like with the Genesis block, I say, hey, make the timestamp this. Here I just must have been using a placeholder timestamp from when I was testing. So that's easy to fix. I can just say, take the current date time and put that in there. But yeah, we're showing this off to get the address of this guy over there. So we can say here, paste that in there, and we can say send. And this will say your transaction for 100 ETS has been successfully completed. Transaction fee of 1 ETS. Okay. So it reloads itself and it says, oh, you've sent this much. Over here we don't see anything yet. This should say 500, right? So you might need to reload it a couple times, or you might need to actually open and close the application in order to retrieve the updated wallet object, which is fine, so we'll do that now. So right now I'm just opening up the node again from source code, and it should say 500. Yeah, excellent. So now we got 500 over here, we got 495 over here. That's a successful transaction right there. that has occurred between the two nodes on our network here. Excellent. Okay, so that's working. This is the testnet of the block matrix concept actually working in action. We can come over here back to our little nodes on our machine. We can come up here and we can look at the first node. It also has its own blockchain and everything, right? So we can say rename here. We can see that this is the address. This is your wallet address. And then BC just means this is the associated blockchain file. We open that up and we can see that this one's all fine and dandy. We got the timestamp working, everything's fine. And we can see that this one has sent 3 right here. This one actually sent it to a different one. Here's the previous hash, the current hash, all that, transaction ID. Here's your wallet ID that's signed by this one. So yeah, this block that is generated here on this blockchain has been sent and successfully received by this block here. When it gets sent and received, it then says a receipt action. This receipt then credits the account and adds it to this blockchain. So that's basically the blockchain functioning and working. It's working. There's a testnet going right now. Both of the nodes are on my machine, but if somebody was interested, they could easily open up a node on their machine. They would just have to get the source code, or I can make a standalone application. So we'll go back to our presentation here and we'll continue on there. So block matrix communication, what actually happened there when we sent it between the two nodes in our network of the block matrix? The block matrix has a backend database containing tables that are representative of the individual blockchains and the assets they contain. When a transaction occurs, a block is created on the initiator's blockchain. A duplicate block is sent to the receiving account's associated database table, where it is then verified by the local vault manager application and then added to the receiving account's blockchain. After verification and confirmation, the associated assets are distributed to the receiving account. So this is what just happened. We can kind of go through a little walkthrough on this diagram here. So let's say test node 1 was X. I added another block to my blockchain. That block data was a duplicate of it was created and sent to a back-end table. And then Y is always calling out, or it calls out when any action occurs, or if you reload the application. Sometimes you need to do that to go and retrieve the information. But when it actually goes and it retrieves this information, then Y will then get this duplicate block data and it will add the duplicate block to its side, of course with its associated action. This will say the action was debiting, because I debited this account, and this will say that it got a receipt of the debit. And all the actions with EBAs and everything that will occur will have their own action and their own workflow that will show it being sent from one side and received from another side, or ownership was transferred from one person to another person. All this is occurring on 2 blockchains simultaneously, or several. This could occur on several blockchains simultaneously, which again is an upgrade and an advancement from a traditional blockchain where it's just unidimensional. This is what it is. Everybody on Ethereum blockchain or Bitcoin, everything, they're just putting blocks on the same chain, and it just validates those blocks, and then it's the DApp side, the DApp, decentralized applications, that are actually doing all of the nitty-gritty here. But here it's actually the DApp, the decentralized application, and the block matrix themselves are actually commingled. They're intertwined, and each one has its own blockchain. These blockchains can communicate with each other, and in that way you get kind of a lattice or a matrix of blockchains that is all decoupled from each other. These assets are decoupled from the blockchains are decoupled from each other. So that's what's going on here with block matrix communication. So we'll go into hybrid encryption now. This actually uses hybrid encryption, which is a little more complicated than just regular RSA encryption, which is used by most of the blockchains out there today. They just use RSA, they use SHA-256, they use all the standards, whatever. So hybrid encryption The Thetis Block Matrix utilizes both symmetric AES encryption and asymmetric encryption. RSA encryption for transaction operations. Wallet information is encrypted using a local symmetric key and is received through a hybrid encryption methodology that encrypts block data with an RSA private public key pair during data transfer operations. This is supposed to be is, not if, so that's a problem, but whatever. We'll just look at this right now. So I'm X here, and I have a wallet. I have a wallet in the wallet file share. So does Y. Y has a wallet up here. We can look at that in a second, just to show what's going on there. And these wallets are encrypted with a symmetric key, which is held on the application side inside of secure data storage. So my X wallet will encrypt and decrypt with my symmetric key. Y will encrypt and decrypt with Y's symmetric key. When I want to send something to Y from X, I called up to my wallet file share, so I'm saying going to the cloud and I'm getting my wallet object. I decrypt it with my symmetric key, and I then send the appropriate data, which is in a decrypted state temporarily, very short, for a very brief amount of time. It exists in a decrypted state where it immediately is encrypted with the public key of Y, and then I send the block data to him. Y has a private key pair, has the private key of the public private key pair. Y will then decrypt what I'm sending to him with the public key, with his private key. Then Y, after has his decrypted information, shoves it into his wallet file share with symmetric encryption. So it's an ecosystem here that's happening with anything that I own is encrypted with my symmetric encryption. Anything that I'm sending is using asymmetric encryption to send it between two nodes on the network. And this is actually revolutionary in terms of how data is encrypted and decrypted in a blockchain scenario. Everybody is just sending openly available data through a private public key pair, which in transit it should be secure, right? But if somebody was to intercept that along the way, and this has happened, right? There's certain attacks that have happened where people find, either from a transaction ID, or a transaction whatever, they get back these private public key pairs. They can figure out weak ones, and they can intercept these blocks and they steal from it. And that has happened in traditional blockchains. Now what's happening here is that if I send you the data, and if this did get intercepted by some chance, and somebody reverse engineered the transaction ID, which has happened, all they're getting is this chunk of data. They're not getting anything from my wallet. They're just getting the chunk of data that's currently in transfer. So whatever transaction is being sent, this wallet is still protected with another layer of encryption. So there's no way that you can backwards engineer the symmetric key from the public private key pair. So it's decoupling the encryption. It's actually way more secure in a lot of ways. So we can look at that now. We can look at that actually. We can go to here, and this is just the central account database on Azure. And we can go here, and these are actually the wallet files here, and they're encrypted. There's no way that you can look at it. If I was to open this up, it'll say access denied. You do not have access. I don't even have access to it as the person that created it. The only people that have access to this information is you on your account. This is using SAS keys and everything in the back end that if people wanted to, I could go through some of the code here to show how this is actually happening. But that's what's happening there. And then since we're in here, we can come here. These are our two accounts right now that exist. And as you can see, the public key is here. So this is the public key, not the private key. So this is available to everybody. So what's actually going on here is that the address itself has been decoupled from this public key, and this public key is huge. If we copy it, we can come over to a new notepad file over here. We can see that this thing is a massive key. It's way bigger than a 256-bit key. Okay, and this is not compressed, anything like that. It's openly available for anybody. So the public key pairs are, the public key is out there available, and there's a lookup table for looking at it with your address. But because of this, they're decoupled from each other. And that makes it a lot more secure, because this symmetric key is decoupled from that. The only way they're connected is through a lookup table. So there's no way that if I get this information that I'm going to get this, like if I get the private key, there's no way I'm going to get the symmetric key. They're decoupled from each other. They're only connected through a lookup table that says, hey, this address is put into the send thing, then get that public key and encrypt it with that, and then the private key is still local to me. So you actually want to protect your symmetric key and your private key in this case. So there's a lot of different keys and a lot of back-end data and back-end operations occurring that aren't visible to the user, because it's a very complex system. So we're going to go now into encrypted blockchain assets. EBAs, or encrypted blockchain assets, are essentially the natural evolution of the NFT protocol. EBA is an encrypted asset that is only able to be accessed and interacted with by the owner of the contract, who owns not only the asset itself, but also an asset decryption key. The EBA is encrypted and then stored on the blockchain as an encrypted asset. Nobody is capable of viewing or interacting with this asset unless they have the AES key it was encrypted with. So a little diagram here. The AES key, that's your symmetric key that we were just talking about. It encrypts this data here. So this is an image file, but in the case of the wallets, it's actually just text. It's a JSON text file, an encrypted JSON text file. But you can encrypt other, like we've tried, or I've tried all sorts of things. I've tried video, I've tried sound files, I've tried image files. Any type of file should, in theory, be able to be encrypted. I'm not exactly sure what the limit of that is yet. I haven't done like a 3-hour video or something to see if it can handle it, but there might be a limitation on the size of these things because of how this encryption process works. But in theory, any file should be able to be used using this this system. And in the future, I should be able to change the size of those files and everything like that by just using better compression and stuff like that. But anyways, so I encrypt this file. This creates an EBA certificate, which is then put onto my blockchain. Now, here's the thing. Wallets themselves are certificate lists. They don't have certificates. They are EBAs, but they don't have a certificate because they're embedded into the system themselves. Like the code for wallets is in the back end. It's not on the blockchain itself. But making, like, let's say I made the Thetis picture here and I encrypted it, this will create EBA certificate. They'll have an owner and everything like that. It could have royalties, all that kind of stuff. And that certificate will then be put onto my blockchain. And I'll say, hey, I own this asset. But the wallet assets aren't done this way. They're just, I mean, in theory, I could do it that way and make a certificate for it, but I mean, because it's going to be transacted to and from so much, you kind of know that the wallet, like when it says the owner of this inside of a transaction is this wallet, you kind of already understand that this is who's sending it to you. You don't need a separate certificate to say this is the asset, because we kind of know that that's who it is based on the whole idea of having an address. So that is then put into your account assets after it's been encrypted. I get the EB certificate onto my blockchain, and then that's that. If I send it to somebody, that'll be the next part here. Asset encryption and transfer. So again, we went over the hybrid encryption that makes this possible. But after a transaction has been completed and the duplicate block data is successfully received, verified, and added to the recipient blockchain, ownership of the associated asset is transferred to the recipient account. The recipient account queries a cloud storage database that holds all the EBAs, encrypted blockchain assets, in no distinct order. This query returns all the account owner's assets, including the assets added in prior transactions, decrypting them on the recipient's end at this time. So again, when an EBA is sent, this is kind of a little different than just sending tokens or sending data over. My account here with my blockchain has a block that says, hey, this is being sent, and it then retrieves the account asset. When I send over the EBA, I'm actually sending the transfer key. So there's a symmetric key here with the X on my side that all these assets are encrypted with my X symmetric key. I will decrypt it and temporarily encrypt it with this is my symmetric key. I decrypt it and temporarily encrypt it with X's transfer key. That transfer key is put into a block data, which is using public-private key pair. I send that over. Y decrypts it with his private key. He will then have access to the transfer key, which allows him to then decrypt this asset here. So the EBA certificate will then be transferred to Y. The ownership is transferred, and then he or she or whoever can use the transfer key to then open up this asset and bring it. And now when it's open, it can go to their account. Ownership has been transferred. They can encrypt it with their symmetric key. So there's a bunch of steps going on there to make sure that everything is secure in transit and that ownership is successfully transferred. But with EBAs, that's how it's going to work. It's going to be using a transfer key and then using the hybrid encryption with the transfer key in order to protect this asset while it's being sent from person to person. So that's that for the presentation here today. We have, again, 2 nodes operating right now. We have test node 2 and test node 1. Transactions have been sent. They have been recorded. Of course, those blockchains are going to be nullified because I got to change the timestamp, which is a simple few lines of code. It's no big deal. But every time that an account is created inside of this test network, it creates a new blockchain. So every account has its own blockchain. So when I make a new test account, new test nodes here, that'll delete the old blockchains and it'll just start up new with new blockchains. So every time an account is made, there's new blockchains being generated, so that the ecosystem can continue to be resilient against anything, right? I guess one last thing that we can show is actually the block in transit here. So I'll go back over to my thing. If I can click here, we're going to be sending from this one again. Test node 2 can send to test node 1 too as well, but we might as well just keep doing what we're doing. So we're going to send 100, and then we need to get their address here. So there will be, inside of our little side menu here, there will be something for looking at your data, your info, to see your address and whatever else. So that's coming in the near future as well. This is like alpha stage, very early in development. Yeah, so anyways, before we send this, I can do a little thing here. I can just put A and see what happens. And it says invalid address. The address you entered does not exist. So I wanted to bring this up before we look at the block in transit there. That you can't even send to somebody that doesn't exist. So if the account hasn't been created yet, you can't even send it. And in that way, like, you can't send stuff to people that, you know, like, let's say Ethereum or Bitcoin or something, they always say, don't remember to double check your address so that you don't send to the wrong person or to some account out there. You can't even do that. It's designed so that you can only send to valid addresses. If it's an invalid address, nothing can be sent there. And addresses are actually created, like when a new wallet is made, the address is generated, the public key pair is then paired with the address, and at that point it exists. But up until that point, it does not exist, and you cannot accidentally send to the wrong place. So that's something that is another improvement over regular blockchains. So let's go over to our thing here. We can go, I think we're at, yeah, this is the right one. Why can't I rename it? Never, oops, fuck. That's not good. Rename. I almost deleted it for a second there. That would have been not very good. Grab our address. Come over here. That's node 2. We want to go to node 1. So we'll send another 100 to node 2. Okay. So now that's there. Before this updates, we'll come over here and we'll go look at the central account database, and we'll see that right now there's currently a block waiting for them. Here's the transaction ID, here's the address ID, and here's the data. The block, and as you can see, the block data, what is it? Well, it's actually this string here. That, this is what it is. This is the data being sent over. It's encrypted currently. Nobody can actually interact with this unless you're the guy that has the private key to decrypt that and to actually retrieve the information. So that's what's going on the back end. So we'll just, which one is this? Is this the right one? 500. We'll close that one down again, and then we'll just go over here and we'll open it up again. And then we see that we have 600 here, so that's reloading. Now that that has happened, we can come back here, we can say refresh, and we see that that's not there anymore. So that's how the backend tables things works, is that all the data is actually in a backend table somewhere, and when you actually retrieve your tokens, it gets that data, it decrypts it, and it just removes it so that it doesn't exist anymore. It only ever exists in a decrypted state. So that's kind of a common theme with everything inside of this whole ecosystem, is that it's always in an encrypted state. There's never a point where it's in a decrypted state, except for temporarily on the client application when you use your own symmetric key to open it up. Alright, so that's about it. I just wanted to go into a little dev log, show how this project is going. I'm very excited. We've gotten to the point where we have the testnet working. We're sending things back and forth. Encryption is working. The symmetric and symmetric AES and asymmetric RSA encryption is working. Token transactions are working between nodes. Everything is going to plan so far. We're actually ahead of schedule, because I thought that this test net wouldn't even be ready until maybe January or February, so I'm a little ahead of schedule, which is excellent. So next up, the focus is going to be, we're going to get these EBA collection views here that show EBAs inside of the wallet, or the app. This is actually an account manager application, but so it's actually a whole account, not just your wallet, right? All your account assets and everything are in here, but the wallet is the thing that holds your ETS token data. So we're going to do that and have it so that you can view, you can view your documents or view your videos and music file inside of here. We're also got to complete the login, and I think I have it open here. I don't. I can go to our little account manager application mock-up here, and we can see that what we're working on right now is we're working on something similar to this: sign in, create account, and then a sign in, and then a create an account buttons like that. So this is what you'll see when you first open it up. You'll have a sign in, and that's what we're working on as well. Working on that. So EBAs is in the near future. Sign in and create account where wallets will actually be created. That's in the near future. And then the other thing that we want to work on is when you click on here, this is going to actually do a transaction to the PayPal account. So there's a lot of work to do there with actually setting up the ETS token and how that's all going to work. So still a lot of work to be done, but the good news is that we're on a roll, and that the actual essential functionality has been implemented. A testnet exists currently, which is excellent. If you view this and you're interested in learning more or running a test node, this for whatever reason, it's very early on right now. Feel free to contact me either on one of the socials that I'm going to be posting this on, or contact me jhallbusiness@outlook.com. There's different ways you can get a hold of me if you're interested. So that's about it for today. Thank you for tuning in and checking out the block matrix in development, and I will be back with another one in probably a couple weeks. Thank you.